Hi, this is Andrea Hendricks. Let's actually now look into applying the law of sines to solve a triangle when we have specific information given. That is, when we know two angles and a side. There are actually two cases for this type of triangle. We have a case where we represent it as AAS, which means angle, angle, side, or ASA, which is angle, side, angle. So that just talks about the position of the side in relation to the angles that are given. So AAS means that the side given is not between the two angles that we know. So let's look at this first case. If we want to solve a triangle when we have two known angle measures, and specifically we have that angle A is 63 degrees and angle B is 45 degrees and the value of A is 16 feet. So I've drawn the triangle here to construct exactly what we need, and now we need to set up a proportion that will allow us to solve for the things that we don't know. So we know angle A and we know side A. We know angle B, so we need to find out what is the value of B. We also need to find out what the value of angle C is and the side C. So to find the value of B, we can set up this ratio that sine A over A is equal to sine B over B and fill in the values that we know. So we have sine of 63 degrees over 16 is equal to sine of 45 degrees over B. If we cross multiply, we get B times sine of 63 is equal to 16 times sine of 45. So all we're doing there is cross multiplying. And in fact, I probably should have put this in the form A over sine A, B over sine B. I'm used to working with the other form, but it really doesn't matter. In fact, in some of the other videos I've changed that, and you'll see that it kind of saves you some steps. So we know that B times sine of 63 is equal to 16 times sine of 45. So dividing both sides by sine of 63, we get B is 16 times sine of 45 over sine of 63. Then just use your calculator. That's all you need to do. Make sure that you close the parentheses around the angles and that you're also in degree mode, and you'll find that B is 12.7 and the units we're working in are feet. Now to find the measure of angle C, that's pretty much a basic fact about triangles. We know that the sum of the angles in a triangle add up to 180. So if you know the other two angles, then you're just going to subtract those from 180 to get the remaining angle. So the remaining angle is C is equal to 72 degrees. So we found two of the three things that we needed to. To find the third thing now, we need to find out what the value of lowercase c is. So now we're going to use the known ratio that we have, sine A over A, and set it equal to sine C over C. And fill in the values that we know. So we have from this that sine of 63 over 16 is equal to sine of 72 over C. Cross multiplying gives us C times sine of 63 degrees is equal to 16 times sine of 72. Then we can divide both sides by sine of 63, and then using our calculator we get that C is 17.1 feet. Now just as a mechanism to check, you always need to look for this, that the largest angle, I should say this, the side opposite the largest angle is always the largest side. And that is the case here, right? Our angle C is the largest, and our side opposite angle C, which is C, 17.1 feet, is the longest side. And likewise, the side opposite the smallest angle should be the smallest side. So that's just kind of a mechanism that you can check the work that you're doing. Now let's look at a next example where we have angle, side angle. So we want to solve a triangle if we know that angle B is 34 degrees, and angle C is 58 degrees, and A is 10 meters. So this time the side that we know is between the two angles that are given. So that's why it's represented as angle, side, angle. So if we know two of the angles, we can find the third angle very easily, right? We just subtract the ones that we know from 180, and we find that we have A is equal to 88 degrees by doing that. Then we need to figure out the missing sides. So we can set up the ratio. We need to first find out what the value of C is, and then we also need to find the value of B. So we set up a ratio involving C and compare it to a ratio of the known values that we have. So sine C over C is going to be equivalent to sine A over A. So plugging in, we get sine of 58 degrees over C is equal to the sine of 88 degrees over 10. And then cross multiplying, so C times sine of 88 degrees is equal to 10 times sine of 58 degrees. Therefore C is 10 times sine 58 over sine of 88. Using your calculator, we get that C is 8.5 meters. And now the last thing we need to do is figure out the value of B. And here you can see I've changed my ratio to put it in the form of B over sine B is equal to A over sine A. So B over sine of 34 degrees is equal to 8.5 over sine of 88 degrees. And you can see this will save you some time. All we need to do is multiply by sine of 34, and we get B by itself. So 8.5 times sine of 34 degrees over sine of 88 degrees is our value of B, which is 4.8 meters. Okay? So that's how we use the law of sines to find out the missing values of an oblique triangle when we know two angles and one side. If you have any questions on that, don't hesitate to contact me. Thanks.